Okay, so let's go and begin today's webinar. So today's webinar is going to be all about a discussion of the Hadoop platform and basically taking a scale of when not to use Hadoop and the primary applications where one should not consider Hadoop because Hadoop generally with a buzzword today has been considered can be used across everywhere. The next 1 hour is going to be a very interesting debate on Hadoop technology and seeing some use cases of Hadoop. So with this, let's go and begin today's webinar. So before even going and understanding now what about Hadoop, etc., I just like give a very small introduction of what is Hadoop. Okay, that helps you a lot. So since we have only 1 hour of time with us, so the first 30 to 40 minutes I might go over the theoretical aspect of the webinar, and the last 20 minutes I like to cover some of the use cases with Hadoop where primarily Hadoop can be used very much effectively. Okay, so maybe I can give a very small introduction on Hadoop even before starting what is the session is all about. So let me give a very small introduction of basically what Hadoop and why Hadoop is all about. So Hadoop is closely related to the big data domain, right? So that everybody is already aware of why we use Hadoop, because the primary intention of using Hadoop is because it is totally a framework which is used for big data domain. So prior to Hadoop, right? So what makes Hadoop one of the most important framework in the market today? So that is the answer we need to understand first, even before understanding when to use Hadoop or when to not use Hadoop. So the primary thing of anybody has to understand is why Hadoop, right? How come Hadoop become a very important perspective in the big data domain today? So to answer this question, so primarily what happens was, as big data means a big data is nothing, lots of data, right? As we start accumulating more and more data, right, we started facing problems like the first thing, the data storage. So how effectively the data storage is going to happen, and also on the data analysis. So a typical RDBMS developer, I hope everybody can able to see the notepad, right? I just shared a notepad. Okay, yeah. So so before as we are discussing of why Hadoop, so as the data gets progress to a, means as an organization, when I might have started with a storage of 20 GB of data, right? So as my organization grows and the data capacity also grows along with the organization, right? So in that case, what happens? So we need an answer for this, right? As as the data keeps growing, is there any system can accommodate how much data is going to come? So I can't define. It might be a 40 TB of data, or down the line it might go to 100 TB of data. Down the line it might go to 150 TB of data. Nobody is in a position to define, right? So that's what the problem started, right? A typical RDBMS cannot solve this problem because an RDBMS is fixed. We are talking about something called as totally and absolutely figure which we cannot come up. It might go to 500 dB, it might go to 600 dB, right? So that's the one problem. And next is the data analysis. So when we talk on the analysis perspective, so is it possible to take the complete 100 TB as an input, right? So this is what the next question comes up, which I am never able to achieve with my current database problems, right? In the current database, I cannot do this. Or in current solution, it may be any solution, not only a database perspective, right? Can I consider the complete 100 TB as an input, or can I consider the complete word hour the data I'm going to use as an input? If I say X amount of data, okay. So finally, the bottom line is the big data put a very simple problem is, if that is an X amount of data, so can you store this X, and also can you do the complete analysis on X, right? So this was the biggest challenge, right? This is the challenge which was put forward to the complete industry. So that's what big data started creating the problem. The primary reason is the database cannot scale up. There's a limitation of every single person is who are using the database is clearly aware of why it cannot handle 100 TB, and we don't want to discuss on that also because That's not the primary reason of using this, correct? Okay, so so in order to answer this, so we come up with a framework called as Hadoop. So that's where basically Hadoop came up in the picture. So it complete distributed data set. So that's the solution Hadoop came up, a complete distributed data set. So that's where basically Hadoop started discussing on it. So let's see maybe a internal understanding of how Hadoop is going to solve this. But this is what Hadoop was trying to solve. Okay, and this is what Hadoop has solved, and that is why we are using Hadoop. It gave us an answer of storing any amount of data at the same time of storing at the same time of doing analysis to any amount of data. Right, there is no such thing like restrictions. There is no certain restrictions on the big data technologies with Hadoop, right? And how it is achieved, let's see in today's session, right? So that's what I want to put forward first. What basically Hadoop is trying to solve, right? So it is a distributed framework, a completely distributed framework, which tries to solve the big data problem, the problem which we discussed called as amount of data, and as well as the complete analysis of data. Okay. So that gives a very small introduction of what Hadoop is all about. So maybe next we can go over the slides and understand when to use Hadoop and when not to use Hadoop. Okay. Is everybody clear on this? You're getting an understanding of what Hadoop is all about? Okay. Fine. So okay, so as we discussed, so that's what basically Hadoop is all about, etc. Everything is fine. So the one important thing everybody has to understand today, what they think is that because Hadoop as a framework is able to solve all the problems, right? So it's not something we should use Hadoop for everything. Okay, because we have a solution like a framework called Hadoop, which can solve the distributed processing of data, right? So we should not conclude something like Hadoop is the solution for everything. So that's not the case, right? There are some scenarios you should not use Hadoop, and there are some scenarios you should use Hadoop, right? So let's consider when not to use Hadoop. So let's consider scenarios where we cannot use Hadoop, right? So let's consider real-time analytics. So Hadoop technically works towards the batch job processing of data. So when I say batch job processing of data, right? So a batch job is something which basically occurs in a batch of files. So if you want any live data analytics, so if you are coming back and asking something like, for example, a tutor data, right? A tutor data is a prime example of live data analytics. So a tutor is like a streaming of data where the data is going to be keep coming on, right? For a particular hashtag, the data is going to be keep coming on. So it's never going to stop. So that is one prime example of a live streaming of data, right? So in those kind of scenarios, Hadoop is not a suitable framework, but there are technologies like a Spark, etc., which is existing in the market today, will run on top of Hadoop to solve this particular problem. But Hadoop alone is not came up with a perfect solution so far for this particular streaming of data. We have Spark and we have something called Storm, so which can run on top of Hadoop to solve this, right? In recent versions of Hadoop, means the current version of Hadoop is trying to solve these problems, the real-time analytics, but technically Hadoop is best suited for the batch processing. Okay, the current versions of Hadoop is now focusing towards solving these problems also, how we can target a stream of data, right? So even that is also they are targeting. So whenever I say a stream of data, means continuous processing of data is called a stream of data. So when I have a tutor kind of scenario for a particular, for example, a sport, right, a cricket or a basketball, so one can expect the data to be keep flowing at any point of time. Okay. Whereas if you are coming back and asking for a complete hospital and you are trying to find what's the total number of inpatients or what's the total number of outpatients, etc., all the things, right? So that is a batch processing. Nothing is going to change big time. Yes, one or two patients might come here and there, but not like a tutor. A tutor is something where a continuous streaming of data is happening. Okay, so real-time analytics is something Hadoop is not suitable. But as I said, the current version of Hadoop, right, uh, 2.5 and 2.6 is having a strong support for this. There are a lot of technologies which is coming on, like primarily a technology called Spark, so which is heavily running on top of Hadoop now. Fine. So which is having a complete support of this. Maybe down the line in Hadoop, more versions of Hadoop, you can see the support of this also. But with the current versions of Hadoop, it's better to use with some other technologies like Spark or Storm to solve this particular problem. But Hadoop alone is very good for solving a batch processing kind of a job, right? So that's one scenario. Whenever real-time analytics come, you should not prefer Hadoop directly. You should have some other technologies running on top of Hadoop. Okay, that is one way, right? So as I was discussing, you can see Spark, right? So I was taking an example of Spark. So whenever a real-time analytics of data is coming up, right, you can use Spark. But again, Spark alone itself cannot give again a real-time analytics. So there is always some amount of gap should be there in processing the data, right? So even though if I say Spark, right, at least a 10 seconds of a delay will be there in the data, right? So if you see the real-time analytics, how it's going to come up today is, as per the current version of the Hadoop, there will be technology called Spark. Spark is just one way, okay? Even Spark is not matured. We have something called Storm. Storm is the most mature things, okay? So the one brilliant thing what Hadoop has done. So I have, you can ask me a question altogether, right? All of a sudden I'm telling something is going to run on top of Hadoop. So when I say something is going to run on top of Hadoop, so let's say I have a Spark or a Storm, okay? So this is keep going. There is no restrictions for this, right? And so we are coming up with a solution by telling, so Hadoop is not preferred for live analytics or a real-time analytics, whereas you can use any one of these technologies on top of Hadoop, right? So now a question can come is that how is it possible for a Hadoop to adapt these kind of technologies? There's a Spark, there's a Storm, there's a Kafka, there's a Flume, there's a S3, and this is never ending. I can point something like some 20 to 30 technologies like this, which can perform live streaming of data, right? So now to answer this specifically, Hadoop is having a very brilliant component called as Yarn, right? So Yarn is one of the important component of Hadoop, which will turn according to the situation. So for example, Hadoop's primary backbone is MapReduce. Okay, MapReduce is an algorithm which is basically coming as a built-in of Hadoop's algorithm, right? And we have all other things like Spark, Storm, Kafka, Flume, etc. All those kind of things, right? So if you're going to submit the job as a Spark, the Yarn will take care of running as a Spark job. And if you're going to submit the job as a Storm, Yarn takes care of running as a Storm, right? So that's the advantage of using a framework called as Hadoop. Even though it is not having a direct support, it can still go ahead and support all the other technologies on top of running it because of the primary support of a built-in component called as Yarn. So Yarn's primary responsibility is to take care of running all these different technologies on top of it. So that makes Hadoop as a standard framework to use. Even though it's not supports directly, it has a lot of components which can run directly on top of Hadoop to support all these things. Okay, so that's one advantage of using Hadoop. So going back to the slide again. So coming back, so you can see here with the difference between a Spark and if used without Spark and if used with Spark, you can see a contrast difference happening in top of the performance ratio, right? So in a real-time analytics, so put forward again in the real-time analytics, it's always better to use a technology, something called as Spark on top of Hadoop or a Storm on top of Hadoop to achieve it. So that's what basically we're trying to interrupt. In the case of real-time analytics, Hadoop should not be used directly. you should be using some other technologies like Spark, etc. on top of it. Okay. Spark depends on the RAM if the data is very huge. Okay, Jay Prasad, Spark ancestor. So Spark internally takes care of the Jay Prasad. Spark is having a concept called RDD and the spillover, which takes care of it. Fine, Jay Prasad. So when you go over the Spark internal architecture, you can get a better picture of it. How Spark is going to handle this. Fine, Jay Prasad. Okay, Spark is okay. So RDD is something a resilient distributed data set, which I feel completely outside the scope of today's webinar, Jay Prasad. I request you to contact the support team on the information on Spark, so you'll get a better picture of it. So fine, Jay Prasad. But to put in a very simple definition, RDD is nothing called a resilient distributed data set, which can recover from itself on any crash. Okay. When Yarn supports Spark, Flume, and others, do they convert all to MapReduce? Definitely not, present. As I said, when you submit a job as a MapReduce, fine. When you are going to submit a job as a MapReduce, it is going to run as a MapReduce. When you're going to send a job as a Spark, it is going to run as a Spark. It will never convert everything into MapReduce. Fine, Prashant? Fine. Okay. So how Hadoop supports? That's what Yarn is a component of Hadoop, Prashant. Yarn is been built up to handle things like that. Yarn is smart enough is going to handle it. That's what Hadoop is trying. So Hadoop and Yarn is not different. Yarn says if you give any job can run on JVM, it can run. That's all. Yarn can run any job which can run on JVM. It has been developed like that. Okay, fine, Prashant. That's the ultimate aim of using a framework called Hadoop, right? So, etc. All the things, whatever it is, if anything is going to be run on JVM, Yarn will support. As simple as that. Okay. How important is to learn Java to get big data? Java is one of the background programming languages which has been used with Hadoop, Venkat. But primarily, I can say only one thing is there are technologies which is coming like Scala, everything, which is again playing a very major role even compared to Java. So it's not like complete Java domination, one can say, because Spark and all is something which has been developed completely with a technology called Scala. Okay, so but knowing Java is going to be an added advantage. Okay, fine, Venkat. So it's but as I said, when you join the course, we'll also provide you all the support on etc. Okay, I have heard Python is also used as scripting language. Yes, Chetna, but Java is having a very strong API. So that's the reason you will be watching Java used a lot compared to even Python. Okay, so you might see a lot of jobs will be running in Java primarily because of the API it is having. Okay. Does Mahout converts all jobs to MapReduce? Mahout 1.0, yes, not Mahout later version. They stopped supporting MapReduce, Kashish. Okay. Core Java is enough for Hadoop? Definitely enough. Ashutosh. Core Java is more than enough. Okay. And also one more thing, Hadoop is not a replacement of the existing data structure. Means the thing is, whenever you're going to fetch the data from the front end, it's always going to come from database only. So what you have to do is that after doing the big data analytics, you're going to transform your data to database. So nothing big is going to change in that perspective. Okay, it's not something the applications need to completely change to use Hadoop. You can still fetch your data from the database. The only added advantage is Hadoop takes care of transforming your data to the database. Okay, as simple as that. Obviously, Elasticsearch better compared to Hadoop. Okay, Padmanabhan, Spark supports Elasticsearch and Spark will run on top of Hadoop. So there is nothing like Hadoop is going to be the base and everything can run on top of Hadoop. So that's what I'm trying to put forward. Okay, maybe I can just show you the Hadoop's. I'll just show you the Hadoop's HDFS how it looks like. So before proceeding to next of the slides. So basically, I'm just going to show you how an Hadoop shell is going to look like. Just to give an indication of how basically an Hadoop looks like. Okay. So whatever I'm sharing is basically one of the Hadoop clusters. So I hope you are all able to see. So this is one of the Hadoop cluster, a single node cluster. Okay, where you can see how the Hadoop clusters is going to be. So it's like a normal file system. There is nothing special like an. It's nothing like an new new kind of technology and all, how a normal file system looks, the same kind of file system. Okay, so it can process any file, either it may be a normal file or it can be an image file. Probably I will show you a demo on both, how to process a normal file, as well as I will show you a demo of how to process an unstructured file like an image. Okay, probably I will try to show you a demo on both of the MapReduce. In next 10 minutes we will start on the demo of how they look like, right? So but the file system of the Hadoop, if you look like, it's exactly looks the same as a typical how your normal system looks like. The only difference between your normal system and this is distributed. The data which is coming here can be distributed across multiple machines. Okay, that's the one of the most important thing. Okay, so apart from that, it's absolutely normal file system. The only thing is, the data is absolutely is distributed in the format of blocks. Okay, smaller section of blocks. So that's one advantage we can use in Hadoop. Okay, so maybe I can show you a MapReduce algorithm for a normal text file. Also, I can show you one of the MapReduce algorithm which can be used for your image file. I will show an example of both how to use it. Hadoop can be used effectively for a structured file as well as for an unstructured file. Okay, fine. So what's the role of J2 in big data? As I said, Astos, the Java EE frameworks, everything remains as it is, right? You're going to still fetch the data from your database only to the front end. The back end processing of data only is changed to a greater extent. Okay, that's what is the main thing. So is it like Informatica? It's more than the Jay Prasad, because there is nothing like restriction in Hadoop. As I said, the cluster can go to any extent. You can extend your cluster to a very greater extent. Okay, fine. Yeah. Did Hadoop require some pre-knowledge? No, nothing like that, Vishwas. It just acts as a file system, so it can just, it's a normal file system, that's all. It is distributed, that's all. Okay, as simple as that. What are these in tables? The database table names. It's completely, you have to come out of your database, Chetna. It is a normal file system. It stores the data in the format of files, not as tables. Fine, Chetna. So you have to remember it as a files. Okay. Fine, Rizwa. I hope you have answered your question. Hadoop is some of the frameworks which cannot be learned as it is from the book, just like that. Okay, so it completely depends on a lot of complexities, etc. It's not like some frameworks like it's not like a language like a Java or a Scala or a Python where you can go and start as it is, right? You should have some level of knowledge, at least some prerequisites knowledge, like understanding the distribution of the file system, and some level of knowledge on Linux. Okay, basically it requires all of kind of things. Okay, fine. So unless or until if you are going to have only a better understanding of Hadoop, so then only you should start using Hadoop for production. Okay, otherwise you should never use Hadoop for production. So it's always, even to start Hadoop, to study Hadoop also, right? It's not that much straightforward to use. Okay.